Welcome to the first video in our series all about programming languages. In this series, we will explore programming languages from a computer science perspective, not just how to use them, but how to understand them at a deeper level. Today's topic is one of the most important foundations, programming paradigms. By the end of this video, you will understand why there are so many programming languages, how they differ, and how paradigms shape the way we think about solving problems. Let me start with a question. Why are there so many programming languages? Why not just one? If you have seen Python, Java, Haskell, or Prolog, you will notice they look very different. That's because each language reflects a different way of thinking about computation. These different ways of thinking are called programming paradigms. Paradigms are like a set of lenses. When you put on one pair, you see a problem in a certain way. Put on another pair, and the same problem looks completely different. A programming paradigm is a fundamental style of building programs. It's not about syntax, it's about the underlying model of computation. At the highest level, we usually divide paradigms into two families, imperative and declarative. Let's explore what those be. So, an imperative language is one where you tell the computer step by step how to do something. The key idea is state change. You have variables that hold values, and your program changes those values over time. Take this example in C. You have an int variable sum initialized to 0, and a for loop runs from 1 to 4, adding loop variable to sum. Here, the variable sum starts at 0 and then changes to 1, then 3, then 6, and finally 10. This is the essence of imperative programming. Give the machine instructions that update state in specific order. In contrast, declarative programming is about describing what result you want, not how to get it. The system figures out the steps internally. Let's take two examples. First, summing numbers in SQL. I can simply write query as select some value from table. That's it. I don't describe the loop or the variable updates. I just declare my intention, give me the sum, and the database figures out the steps internally. But the declarative programming is broader than SQL. It also includes logic programming, where you state relationships and let the system infer new facts. Here is a simple program in Prolog where parent relationship is given between two persons and grandparent relation is defined in general. And here we don't compute step by step who the grandparents are. We just declare the facts and a rule. If we now ask, is Alice the grandparent of Charlie? Prolog can answer yes by chaining the rules. This is another form of declarative thinking. Focus on the relationships, not the procedure. Now let's refine the picture. Under the imperative family, we have procedural programming in which the code is organized into functions and procedures. Languages such as C or Pascal are based on this paradigm. In object oriented programming, we bundle state and behavior into objects. Java, C++ are using this particular design strategy. In concurrent programming, multiple computations are happening at the same time. Go and Erlang are examples of such languages. Under the declarative family, we have functional programming and logic programming. Functional programming treats computation as evaluation of mathematical functions, often avoiding mutable state. Examples are Haskell, Scheme, OCaml. In logic programming, whose example we just saw, we express facts and rules, letting the system infer answers. The classic example is Prolog. Each of these sub-paradigms emphasizes different ideas about computation. So why should you care about paradigms? Because paradigms shape how you think about problems. Take concurrency. In an imperative language like Java, concurrency often means sets, locks, and risk of deadlocks. But in Erlang, which is concurrent language, concurrency means independent processes sending messages to each other. The model itself makes some problems easier to solve. When you understand paradigms, you stop asking what's the best programming language and start asking what's the right paradigm for this problem. To summarize, imperative programming tells the computer how to do something step by step. Whereas in declarative programming, you specify what result you want and leave it to the system how to evaluate it. We also saw that each family has sub-paradigms that highlight different styles, like object-oriented programming, functional programming, or logic programming. By learning paradigms, you build mental flexibility. Each new paradigm gives you a new way of thinking about computation. Thanks for watching. Don't forget to like, share, and subscribe if you want to follow the rest of this journey into the world of programming languages.